Hi there, my name is Greg Tilka, and I'm a professor in the Department of Plant Pathology and Microbiology at Iowa State University. And today I'd like to provide you an update on the situation with soybean cyst nematode. Now, many of you may know or have heard that soybean cyst nematode is the most damaging pathogen of soybeans in the United States and Canada. And hearing that or hearing someone say that may evoke thoughts of an image like you see here on the screen right now. And that certainly is a possibility with soybean cyst nematode, particularly in hot, dry years. But more often than not, in years of adequate or excess rainfall, there are no obvious above-ground symptoms. And so it's a big problem for us in that many SCN-infested fields look like the image there on the right. But if you would dig roots during the growing season and look at the roots, you would still be able to see the telltale adult females on the roots. That is an indication that indeed the field's infected or infested with soybean cyst nematode, the plants are infected. Now, soybean cyst nematode is widespread throughout the United States. It's becoming more widespread in Canada. And the most recent map of the counties known to be infested with SCN was published in early 2021 with information through 2020. And you see the map there on the screen. You'll notice that certain states, namely Iowa and Illinois, are all colored in. That simply means that SCN has been found in every county, but it doesn't mean that every field is infested with soybean cyst nematode. To get that level of information, one would have to do a survey of individual fields, and we had a very large project in the mid-1990s where we partnered with the USDA National Ag Statistics Service. They randomly selected fields in the states you see on the screen, and we paid them to pull soil samples. Every dot on the slide or on the map there represents a sampled field. All those soil samples were sent to Iowa State University where we processed them for soybean cyst nematode. And here is the percentage or incidence of infestation we found in the various states. And so for Iowa, 3 out of every 4 fields that were sampled in that survey tested positive for soybean cyst nematode. In Illinois, it was 4 out of 5 fields, or 80-some percent, and you see the various other percentages there. Now, at Iowa State, we have repeated that survey twice since the mid-90s. We did it again in the mid-2000s, again cooperating with the National Ag Statistics Service, and we found SCN in 71% of the fields in Iowa then, and then most recently in 2018, we did a random survey a third time and found it in 73% of the field. So SCN is certainly widespread in the state of Iowa, and farmers need to be aware of it and need to be on top of it in terms of managing this pest. So managing soybean cyst nematode really comes down to 3 main things, and those are using non-host crops and resistant soybean varieties in rotation, and then also taking advantage of relatively new nematode protectant seed treatments. And so I want to touch on each one of these individually. For managing SCN with non-host crops, the point is that numbers will drop any year that you grow a non-host crop. And so what happens in SCN-infested field when a non-host crop is grown, eggs in the soil, such as the one shown on the left in this image, will release the juveniles. The juveniles hatch out of those eggs, and those juveniles, such as the worm on the right there, are a weak link in the life cycle. If they don't get into a host root within a matter of days or weeks, they're either going to starve or something else that lives in the soil is going to eat them, parasitize them, or actually insects and mites could eat them. So what we've seen over the years in Iowa is that 1 year of corn following soybeans can drop numbers as little as 5 or 10% to as much as 45 or 50%. And again, this is because eggs are hatching out, those juveniles are starving. Unfortunately, we don't see the same level of decrease in a second year of corn or a third year of corn. What we see really is there's much less decrease in numbers after the first year corn when we get into a second or third year corn. And the reason for that is when soybean cyst nematode females produce their eggs, many of those eggs from the very beginning are dormant, and they're programmed somehow genetically to not hatch just when conditions are appropriate, when the soil's warm enough and moist enough. They're not going to hatch until a period of time, which could be as much as 8, 9, 10 years go by before those eggs hatch. And so we see most of the non-dormant eggs hatching in first year corn following soybeans. There may be some more non-dormant eggs hatching in second year corn, but eventually the decrease in egg numbers flattens out as we get past a couple years of corn or any other non-host crop. So moving on to cyst-resistant soybean varieties, this is the foundation of managing soybean cyst nematode, and when it works really well. So in the image here on the screen, cyst-susceptible soybeans were planted on the left, cyst-resistant soybeans were planted on the right, and you literally can see differences as dramatic as this. Without the resistance, the soybeans are stunted and yellow and chlorotic, and obviously those unthrifty looking soybeans are going to produce less yield than the vigorous soybeans on the right. And the best bargain in the world that I've ever encountered in crop production is that the seed industry doesn't seem to charge a premium for seeds of cyst-resistant soybeans. Not even back 25, 30 years ago when there weren't very many cyst-resistant varieties to pick from, and most varieties were susceptible to soybean cyst nematode. So how does that effectiveness, that vigor of resistance look in terms of data or in terms of real-world numbers? I tell farmers that cyst resistance pays you twice. And the first payment is pretty obvious. It's in the form of yield. And so here are some data from a variety trial we did in East Central Iowa. The starting egg count was about 1,300 eggs per 100 cc's or half a cup of soil. And at the end of the season, the light bar is the average yield of 60-some resistant varieties that were in the variety trial. The dark bar is the average yield of 3 or 4 susceptible soybean varieties that were included in the experiment. And you can see the difference is pretty dramatic. That's money in the bank, it's beans in the bin, plus 6.8 bushels per acre. And so that's the first payment that comes due, or is paid out, I should say, for farmers in growing cyst-resistant beans. But there's another valuable payment that occurs as well. So the 2 bars that have just popped up on the screen on the right are the end of season SCN numbers under the plots that produce the yields that are shown in the left 2 bars. And so in addition to that yield benefit, we saw in this experiment, and it's very typical, that the egg count stayed about the same under the resistant soybean varieties, but egg counts were almost approaching 9,000 at the end of the season under the susceptible soybeans. And that nematode control, those low egg counts in the left bar on the right side of the graph, will pay additional dividends in terms of soybean yields in future years when soybeans are grown in this field. So since cyst-resistant soybeans are the foundation of our management of SCN in the state, I have a very keen interest in it. And throughout almost all of my decade, I've been tracking what the industry is making available for farmers to grow in terms of cyst resistance. And here you see a bar graph of the number of SCN-resistant varieties that were available for farmers to grow in Iowa from 1991 all the way up until this year. We update the map, or not the map, the publication, the list, in the fall every year. And so the most recent publication, which I'll show in a minute, was just put out online in October of this year, I should say of 2021. And so in 1991, that list fit on the front page of a single sheet of paper. and the list for this year has 872 varieties. So this is what that publication looks like. It's available for download on the ISU Extension website. The actual web address is shown there on the screen, or you could just literally Google ISU Extension PM1649. It will take you to the page where you can download the PDF file of this publication for free. So soybeans are not naturally resistant to soybean cyst nematode, but soybean breeders and soybean geneticists have found some unique soybean lines that have resistant genes in them. Now, unfortunately, those soybean lines, breeding lines, are horrible agronomically. Many of them are black seeded, or they don't grow upright. They grow kind of on the ground, almost like morning glory. And so plant breeders, through their magic, are able to cross those undesirable agronomic breeding lines with valuable resistance genes with high-yielding agronomic varieties to produce high-yielding agronomic varieties that also contain SCN resistance. There are 7 main breeding lines or sources of resistance that breeders use. They're shown in this bullet list here. And the names on the right side of that list are the plant geneticists and breeders that published acknowledgement that these were available for use in breeding cyst resistance. And then at the bottom, it mentions that there are many other breeding lines that people have published and talked about that are available to make crosses with to try and produce cyst-resistant soybeans. But the bullet list is the main 7 that are talked about and considered among scientists and the seed industry. So earlier I showed you a bar graph of the number of SCN-resistant varieties since 1991. Here is that same bar graph, but here I've colored in the bars, and I'm showing the different genetics that are available. And the PI88788 genetics is shown in each bar in the light color, and then in the bright red portion of each bar are the number of varieties from all other sources. So clearly, our soybean variety selection is dominated by PI88788 as evidenced by this bar graph. I mentioned that we updated the 2021 list, and in that there were 872 varieties total. Of those 836 had PI88788. 34 had the second most common source of resistance called Peking, and then there were 2 varieties available that had resistance from PI89772. One last point I want to make about these SCN-resistant varieties on this slide is that even though there's 836 varieties available to grow in 2022 that have PI88788 SCN resistance, they don't all provide the same level of SCN control. It can be quite variable. And here are some data from 2021 that illustrate that point. So here are variety trial data, and what I've plotted was the average yield of 70 different varieties that have PI88788 SCN resistance. The yield is on the vertical axis, and on the horizontal axis at the bottom is the end of season egg count that was left after the soybean varieties were grown. And we started out with a relatively low egg count, below 2,000 in that field, and by the end of the season, the varieties that allowed a large amount of reproduction, as evidenced by the dots on the right side of this graph, end of season egg counts of 35 or 39,000 eggs per half a cup of soil, also were the lowest yielding, around 40 bushels per acre. So this illustrates that not all varieties with PI88788 SCN resistance control the nematode equally well, and that nematode control is fairly well correlated with the yield that is being produced by those soybean varieties. So varieties with better SCN control leave behind lower egg counts and yield better. And I mentioned earlier, those lower egg counts at the end of the season will pay dividends in terms of better soybean yields in future years when soybeans are grown in a particular field. So because all those 88788 varieties don't control the nematode equally well, we conduct a variety trial program. We've done this since the 90s. It's funded through checkoff dollars from the Iowa Soybean Association, and each year we do 3 experiments across northern Iowa, 3 across central Iowa, 3 across southern Iowa. They're not always at the exact same locations, but they fall into the same 9 crop reporting districts. Another key point here is that we do these experiments in farmers' fields, and because of that, we feel that the results we obtain are indicative of what farmers would attain or obtain should they grow these varieties in those general locations. We never go back to a field, a specific area of a field twice. We only do that once, and then we'll never go back to that area. We always want to follow corn. We may work in the same field 2 or 3 times, but we will conduct the experiments in different parts of the field. And even though these are large variety trial experiments, they only take between 3.5 and 5 acres. So we're renting a small part of a much larger field from these farmers. The results of that work is published every year in another ISU Extension publication. This would have been released in January of 2022. It is a special insert in Iowa Farmer Today, the second week of January 2022, and it's available online as well at the web address you see there, or as before I mentioned, you could just Google ISU Extension PM52, and it should take you to the online extension store where you can download a PDF file of this report for free. So back to these variety trial experiments. I mentioned they're only 3.5 to 5 acres of a much larger field. Our general unit of study is a 4-row plot, so 4 rows wide by 17 feet long, and we're able to fit in 72 varieties replicated 4 times in an individual experiment. So this is the type of experiment that would be conducted 9 places throughout the state of Iowa. Each yellow dot that's just popped up on the screen isn't a single soil core, it represents a 10-core sample from an individual 4-row plot. So those dots you see on the screen represent a total of 2,800 soil cores among the 280 plots that are in that experiment. We do this sampling at the time when we plant in the spring, and we do it again when we harvest in the fall. So we will have initial and final egg numbers, egg population densities in each plot, and then we also harvest the center 2 rows of each 4-row plot. And then finally, we also measure, and we want to learn and know what's the status of the nematode that lives in that particular field. So we do a study, a virulence or aggressiveness test on the SCN population that's in that field at the beginning of the season. And we use the leftover soil from the soil samples that we collect at the time of planting. So effectiveness of SCN resistance on populations of SCN in the state of Iowa is very important, since resistance is the foundation of our management strategy. And we do this test, it's called an HG type test, on the SCN population in every field in which we do an experiment. It's a greenhouse test of reproduction of the SCN populations against the 7 main sources of resistance. I say every field we have data from nearly 300 tests that we've done over the years, and we're always most interested in the level of reproduction of SCN in a field on these first two breeding lines, because those are the ones that are in varieties that are sold to Iowa farmers. So this test is a 30-day greenhouse test. The results are called a female index or percent reproduction. And what we do is we take all the leftover soil from the spring soil sampling, we mix it up real well, and we fill up a bunch of containers and we plant multiple replications with seeds of each of these 7 main breeding lines that I've mentioned earlier. We put all those cones or containers into buckets of sand. We have them set in a temperature-controlled water bath for temperature control. We grow them for 30 days, and this is what the soybean plants look like at the end of those 30 days. And then one by one, we carefully remove the plants and roots from each cone, including susceptible plants as a reference point, and we count the number of little white females that form on each root. And here we see an image with lots of little white females on the roots. That would be a susceptible soybean plant, and that's our reference point. And then we can calculate how much reproduction occurred on those sources of resistance compared to how much reproduction occurred on the roots of the susceptible soybeans. And that's how we come up with that female index or percent reproduction. So taking a look back over 30 years on those levels of reproduction of the SCN in the fields that we've ever worked in over 3 decades, in the decade of the 90s, almost every SCN population we ran into in any farmer's field had low reproduction on pure PI 88788, less than 10% reproduction. And that's a key point, that less than 10% reproduction is what the scientific community considers resistance to SCN. Now, another way to think about below 10% reproduction is that the source of resistance, 88788, is providing greater than 90% control. So percent control is kind of just the converse of how much percent reproduction was allowed. At the end of the day, what this really means is that 88788 worked really well in the decade of the 90s. But on this graph, I'm plotting those same types of data. Percent reproduction is on the vertical axis on the left versus the years from 2000 to 2021. So there's 22 more years of data. And each blue dot on this graph represents the SCN population in a farmer's field. And so you can see all the dots for 2000, the year 2000, were still below 10%. And I've highlighted the magic green 10% level is highlighted in green. That's where resistant reproduction should be, below that 10%. But then we see a troubling trend progressing as we move through the years of the last 2 decades, and we encounter more and more fields with SCN populations that have higher and higher levels of reproduction on PI 88788. And that's representing the loss of effectiveness of that source of resistance. Now, looking back at the same type of data, but for Peking resistance, in the decade of the 90s, it worked extremely well. We saw virtually no reproduction on pure Peking from any SCN population we found in any farmer's field. And then here is a graph formatted very similar to the last graph I showed you. Percent reproduction on the vertical axis on the left, the years from 2000 to 2021 across the bottom, and the red squares you see here now represent the level of reproduction of SCN populations in farmers' fields on Peking. And in the year 2000, you see all the squares are below the 10% level, and even in 2001 and 02. And we do see, as we go through the last 2 decades, we encounter here and there, every once in a while, an SCN population in a farmer's field that does have a higher level of reproduction on Peking, but it's certainly nothing like the situation with PI 88788. And in fact, the PI 88788 trend here in the graph on the right is troubling, but it's not surprising when you consider the bar graph I showed earlier that shows the source of genetics for resistance that farmers have available for them to use. So it's a real problem, but it's not unexpected, and it's kind of a slowly developing trend that shows no signs of changing. So that loss of effectiveness of 88788 resistance has real consequences for farmers. So here are variety trial data from an experiment we did in southeast Iowa in 2019. And in that experiment, there were 3 susceptible soybean varieties. There were 2 Peking varieties on the left in green, and all the gray varieties in the middle had PI 88788 resistance. And what is shown on this bar graph is the yield of those varieties. The average yield of all those numerous PI 88788 varieties was 51.2 bushels per acre, and the average yield of the 2 Peking varieties was over 72 bushels per acre. Now, I mentioned that these experiments, while large for experiments, only take up 3.5 to 5 acres of a farmer's field, and so the farmer farms around our experiment. And the farmer who hosted us for this experiment happened to grow a soybean variety that was in our experiment as well. And so there is the variety grown by the farmer, and he grew it around us. And so I did a crude calculation, and if the farmer obtained 50 bushels per acre in the 25 acres around us instead of 72 bushels per acre, that's a 22.4 bushel per acre yield difference. Soybeans were worth $9 a bushel back then. That farmer lost out or missed out on nearly $200 in revenue an acre because of unfulfilled yield potential by growing an ineffective source of resistance. And then if you multiplied that by the 25 acres of his land around us, that yield loss was approaching $5,000. So it's a real consequence, this loss of effectiveness of 88788 resistance. Oh, and on top of that, you've heard me mention before, end-of-season egg counts will affect yields in future years when soybeans are grown again. We averaged the end-of-season egg counts for all these plots, and under PI 88788, all of those varieties, the average end-of-season egg count was over 14,000. The average egg count under the susceptibles was 13,600, and the average egg count underneath the high-yielding Peking varieties was 800 eggs per half a cup of soil. That is a tremendous difference between Peking and 88788, which undoubtedly will affect soybean yields in the future. So the third prong of our management scheme for soybean cyst nematode presently is seed treatments, nematode protectant seed treatments. And we at Iowa State University, with funding from the Iowa Soybean Association, conduct field experiments. We conduct them right beside our variety trials, and so the aerial image you see there on the right show a seed treatment experiment right next to variety trial plots. As the second bullet point states, we test the nematode protectant seed treatment compared to its base, because these nematode seed treatments are always on top of a base of fungicide and or insecticide. So an example would be Clariva is a nematode protectant seed treatment. It was sold on top of Cruiser Max Advance plus Vibrance. So the two treatments we compare are Clariva with Cruiser Max Advance plus Vibrance compared to just the base of Cruiser Max Advance plus Vibrance. Now, we've done many of these experiments as listed at the top, 182 so far. We use the same plot setup as variety trials. But we do 12 reps of each treatment compared to 4 reps for a variety trial. So this is pretty highly replicated. Same 9 locations as variety trials throughout the state. And it's basically the nematode protectant seed treatment with and without its base. It's always on top of, the treatment is on top of a resistant soybean variety, and we ask the company who is marketing the seed treatment to suggest or provide us with that resistant soybean variety. And just like variety trial experiments, we measure yield, but also beginning and end of season egg counts. Now, we don't have time in this presentation to go through every seed treatment that we've ever tested and all the different years and so forth, but I've produced a nice summary table that is shown here. It shows the various products that we tested throughout the years on the left. The second column from the left is the years that we conducted the experiments, and we typically do about 3 experiments every year, And so you'll see there's 3 seed treatments that have the word 21 or the number 21 on it. In 2021, we did field experiments with Alivo, with Saltro, and with Trunemco. The third column from the left is the number of times that in an experiment we've detected a significant yield increase with the nematode protectant seed treatment compared to its base. And here you see the number of times that happened out of the total number of experiments we conducted, and then I've calculated a percentage that's shown there in the blue font as well. And so unfortunately, we see a wide range of yield responses in terms of frequency of a yield response, from as little as 0%, and the best we've seen is a 22% positive rate of yield increase. And this is lower than what's reported by the industry, and sometimes from some larger scale experiments such as strip trials as well. So we're not completely sure why the positivity rate is as low as it is, but we do see some significant yield increases occurring. And then the rightmost column shows the magnitude of the significant yield increase when it occurs. And there you see a range of yield responses. When they are significant, there's the range that we've detected. Now, if you pencil out the cost of the seed treatment and then the current price of soybeans, and since these experiments were conducted over a wide range of years, that we see a wide range of the price of soybeans, the break-even point is usually, again, depending on the price of soybeans at the time, between 1 and 3 bushels per acre. And when you look at the right column on the table, more often than not, when there is a significant yield increase, it more than pays for the product. And so the thing we struggle with is how to figure out when to get better positive results. Some of it might be, as I mentioned earlier, due to our experimental methodology, but I do think there's some local conditions that affect the likelihood that any individual seed treatment is going to provide a positive yield response. And the final thing I wanted to mention about our experience with seed treatments is that rarely do we see significantly lower end-of-season SCN egg counts after using a nematode protectant seed treatment, even in experiments where there was a positive yield response. And that's just a fact in terms of our data, but it doesn't trouble me because I think it's very unlikely that any seed treatment would be able to provide season-long control of SCN numbers. And when the protection wears off at some point during the season, there's a healthier root system there because of the protection. And that root system is a great source of food for the SCN population that's still in the soil. And so we see a resurgence of numbers at the end of the season. And the reason this doesn't bother me is if we rewind science about 4 or 5 decades, the nematologists that studied soil-applied nematicides saw really good knockdown of numbers of nematodes in the early season, but even that protection wore off. And by the end of the season with soil-applied nematicides, there was a resurgence of the numbers of the nematodes, and very often you didn't see a difference. Even though there might be a yield difference, you didn't see a difference in nematode numbers. So that's the current situation. Let's talk about managing SCN in 2022 and beyond. First off, we want you to continue, farmers to continue growing non-host crops. And another way of saying that is beans on beans is a bad idea in fields that are infested with SCN. So we need the year of non-host crops. Even a couple years in some situations would do a field good if it had high levels of SCN. We need farmers to continue to grow SCN-resistant soybean varieties. They're probably going to mostly be 88788, but farmers should actively seek out varieties with resistance from Peking. And there's also 2 varieties available with this PI 89772 source of resistance. For those people that might be able to get a consistent supply of seed of varieties with Peking resistance, need to caution you to do not grow those continually. The resistance will probably break down quicker than the resistance that we saw with PI 88788. And so if you can get the seed, you should alternate growing varieties with Peking and with 88788 resistance in your soybean years of your rotation to avoid us losing the effectiveness of those Peking resistant soybean varieties. There's researchers funded by the Soybean Checkoff that are looking at new resistance genes and bringing them into existing breeding lines for the industry to use. And these soybean varieties with Peking and 89772 and new resistance genes, farmers can only grow what's brought to market to them by the seed companies. And so farmers are the customers, and if you think that this is a serious situation, as a farmer customer, I think you should express that concern with your seed suppliers and perhaps encouragement that you would willingly grow these varieties to kind of get our arms around and start putting an end to the unneeded yield loss due to SCN, because all the resistance, or virtually all of it, is PI 88788. And then a bit of positivity or positive note to end on with resistance is the EPA gave approval to BASF in 2020 to advance development of a transgenic Bt resistance for soybean cyst nematode. And in June of this year, scientists who were working on that project in BASF published a paper. And the paper is probably pretty technical for most audiences, but every paper has a summary or an abstract at the beginning. If you would like to see that paper and read the abstract or the entire paper, you could just Google cry protein and SCN, and it'll take you to the web page where you can download this PDF file. So that's it for resistance. Nematode protectant seed treatments, that we need to continue working with those and using those as well. I have a feeling the 9 variety trial locations where we do seed treatment studies is not effective enough to provide information that's going to be useful to all farmers in Iowa. It's just meant to be a starting point. I really think this is a topic that needs a lot of on-farm testing by farmers, and that would require careful record keeping to try and get some observations at the local level to find out what seed treatments seem to work well in particular local environments.